talking on flux quantization, F theory, and the Freed-Witten anomaly.
Okay, thank you very much. Can you hear me? Okay, so I would like to thank the organizers for giving me the opportunity to speak here. So my talk will be about flux quantization in F theory and its deep connection with the Freed-Witten the perturbative version of the Freed-Witten anomaly that you get in type 2B string theory. And this is a work done in collaboration. I mean, it's based on two papers I've done in collaboration with Andrea Scolimucci. So let me outline the ideas and the purposes of the work. So I don't have to convince you that global issues, global aspects of F theory configuration are of crucial importance for many aspects, both on the phenomenological side and on the more formal side. For instance, one of these examples is, for example, it's the quantization of fluxes, and I will show you that this is intimately correlated with the Freed-Witten anomalies in type 2B string theory. And of course, a detailed understanding of how to treat fluxes is of crucial importance for various issues like moduli stabilization and generation of chiral matter. I will focus on this kind of compactification of F theory on a Calabi-Yau fourfold, which leads to n equal to 1 theory in 4 dimensions. And I will define F theory as a M theory on the same Calabi-Yau fourfold, which has to be elliptically fibered in the limit of vanishing volume of the generic fiber. So the picture of the entitled manifold is this one, where you have a base manifold, which is a 3-dimensional Kähler space. The total space of this fibration has to be Calabi-Yau, and the typical fiber is a 2 torus. And these red dots here are the position, the location of 7 branes in which one of these one cycle of the 2 torus is collapsing to 0 sides. I will not need too many details of this duality, but I will just stress that I have, I mean, on the F theory side, I have just one flux, which is the G4 flux, and this gives rise to both type of fluxes in type 2B compactification, which is bulk fluxes, which at H3 and Ramond F3, and also to gauge fluxes on the 7 branes. And the duality says that in order not to break Poincare invariance or Lorentz invariance in 4D, the G4 flux in M theory has to have one and only one leg along the torus. And this has a big importance for what is following now. So in particular, we want to study the aspect of flux quantization in F theory. So we know that so Witten in 1996 studying the quantum theory of membranes propagating okay, in this case it's a Calabi-Yau fourfold, but his analysis was more general. This theory is anomalous in general unless you quantize properly the G4 flux in this way. But now you see that there is very soon an issue for smooth elliptic Calabi-Yau fourfold since C2 has either 2 legs or no legs along the fiber. So this is an issue because if C2 is odd for smooth Calabi-Yau fourfold, then for sure you would induce a G4 which you cannot put to 0 because it's half quantized, and this G4 would for sure break the Lorentz invariance. But actually we have showed in 2010 that luckily this C2 is always an even class when you compactify F theory on smooth elliptic Calabi-Yau fourfold. So that means that only in case where there are singularities of the Calabi-Yau fourfold you should expect some half quantization of the G4 flux. And in particular we have studied the SU series and the SP series. In this talk I will focus mainly on the SU series, which is phenomenologically more relevant. And we found that actually half quantization of G4 flux arise exactly when the singular locus, I mean the singular locus of the Calabi-Yau fourfold is a non-spin manifold. And this reminds you the connection to the Freed-Witten anomaly of the corresponding D7 stack sitting on this locus, which I remind you is this one. It's essentially the correct when I speak about Freed-Witten anomaly in this talk is about the flux quantization. Then there is the Freed-Witten anomaly which restricts the topological type of the H flux, but I'm not concerned with that in this talk. So these two things are essentially the same thing. One viewed in the M theory and the F theory side, and the other view in the viewed as in the weakly coupled description. Okay, so now what's the aim here is to to find a direct and explicit map which associate to the two cycle on the Ward volume of the brain which detects this Freed-Witten anomaly, associate to it the lift 4 cycle in the Calabi-Yau fourfold on which we detect the M2 anomaly. So I just want to find this explicit map. So remember, detect Freed-Witten anomaly here means that I integrate C1 over this C2 and I get an odd number. I want a C4 in Calabi-Yau fourfold on which if I integrate the C2 of the Calabi-Yau fourfold I get an odd number. I will split this discussion in two parts essentially. So first I will treat the SU even cases which are easier to deal with, and also the physical picture will be more intuitive. So let me start. Let me take, for example, so to draw a picture, I will stick with the SU4 case, which is the easiest. I mean, SU2 would be the easiest, but it belongs to the SP series because it's SP1, so I won't discuss it now. So let's stick with SU4. So once you have an SU4 singularity, then you have to blow up it, and once you blow up on the SU4 locus, so you find the extended linking diagram of the SU4. So this is the extended node. These are the three Cartan nodes of SU4. These green sticks here are, I mean, this is a type 2A picture. Essentially, these are the D6 brains, and there are type 2A open strings stretching between these brains. And the Cartan nodes can be regarded as S1 fibration over the corresponding open strings. And this, since the M theory S1, that is this fiber here, is shrinking on the location of the D6 brain, this leads to a closed M2 brain in M theory. Okay, now we have to consider, so in order to detect Freed-Witten anomaly, we have to take non-contractible loops of open strings, of type 2A open strings, which stretch from I D6 brains to the J D6 brain. So such a loop can lead to two things. One is a loop of boundaries, both of the D6I and the D6J, and this loop of boundaries are our the candidate two cycle on which to detect the perturbative Freed-Witten anomaly. But also, if you fiber the M theory S1 over these strings, you get loops of membranes. And this picture, you find this loop of membranes as these Cartan nodes fibered over this C2. And this C4 is actually our candidate 4 cycle in which to detect the M2 anomaly. Okay, the problem is that, I mean, it's not so easy because if you use any of these Cartan nodes and you fiber it over C2, you get for sure an even number for C2. So this C4, candidate C4, cannot work in our case. And the reason is very easy, and it is also very intuitive physically, because once you, so take for example the E3 node fibered over the 2 cycle, and you try to integrate C2 over 2, and you want an half integral number to detect the Freed-Witten anomaly, but what you get is an integer number, because you get two contributions, one from the flux on this Freed-Witten anomalous brain, and the other from the other flux on the Freed-Witten anomalous brain 4. So two half integral contribution make an integral contribution. And this is compatible with the findings of Sven, Christoph, and Timo, who found that actually if you use any complete intersection 4 cycle, then you measure C2 and this is always an even number. So things are a little bit more complicated. We have to use a strategy, and the strategy is actually quite intuitive because what you have to do is to somehow use strings, open strings that stretch between some brain that has the Freed-Witten anomalous, the Freed-Witten half quantized flux, and some other brain which is fluxless, either fluxless or it has an integral quantized flux, so that this sum will be half integral. So this is just the statement that I made. What is this? So are there candidates for fluxless brain? Yes. A natural candidate is the Whitney umbrella brain, which is the one that cancels the D7 tadpole and carries an O1 gauge group because it is invariant under the orientifold. But to get these nodes, which lift such an open string, we have to go to some matter curve where I mean, some of the Cartan node splits and we get an enhancement. And the matter curve in this case is the fundamental matter curve. So the curve where the fundamental matter sits, which is the intersection between this Whitney umbrella brane and the 7 brane stack. The problem is that there is still one issue. One is tempted to pick as our candidate 2 cycle to be exactly this intersection here. This will not work because, I mean, if you try to compute C1 here, it would be for sure an even number because the Whitney umbrella is a Freed-Witten anomalous brane, and so this will not work as a 2 cycle. What we did to avoid this problem, okay, thanks, is to constrain the complex structural moduli space of the Calabi-Yau fourfold in order that this curve of intersections become reducible, and we choose just one of the component to be our C2. So this avoids the problem of having a complete intersection C4. So once you do this constraint, then automatically in the Calabi-Yau fourfold there are more holomorphic 4 cycles coming up. I mean, they appear some holomorphic 4 cycles. I mean, this is the correct mathematical statement. I mean, these 4 cycles are always there, but they are not holomorphic generically. And this is a phenomenon widely used in this paper. So in particular, these orange nodes fibered over our C2, which is this one component, gives you an half quantized G4 flux. And notice that this is not so it's not a problem for chiral indices because this is just one component of the full fundamental matter curve. So there is no reason why G4 has to be quantized over this matter surface. Let me just show the general result for, so we have treated the whole tower of SU2n, and this is essentially the general result in which you can see that the C2 integrates to an odd number exactly when the class of the 7 brane in type 2b string theory is odd, and vice versa. The same procedure, exactly the same procedure with the same physical picture can be used for treating the SPN series. Let me just mention very briefly the SU2n plus 1 series, which is a little bit more difficult, and then I will conclude. Here the problem is that I mean you cannot use anymore the Whitney umbrella because when you try to go to the SU odd, then the Whitney umbrella splits in 2 parts. One is the 5th brane, in this case 5th because I'm discussing SU5 here, the 5th brane of the stack, and then the rest has to be a non-spin surface. And so when you try to connect with open strings, you get the same problem that you get two half integral contribution. So you have to find out some other things. So the same we can use the same strategy, but we need essentially a different fluxless object. And what is this other fluxless object? There is a natural candidate on this, also in this case, which is the orientifold plane. So we have to just change the matter curve. Instead of considering the matter curve with fundamental matter, we consider the antisymmetric matter curve, which is this intersection here. Again, we constrain the complex structure moduli space of the fourfold in order that this guy is reducible. So we pick one component. Okay, the picture of the enhancement here is a little bit more complicated because we get an enhancement not to SU6 but to SO10 because we are on the orientifold. And this is I mean, you can recognize here the affine equilibrium of SO10, even though it's a little bit more difficult. But I mean, the strategy is exactly the same. Again, for this constraint, new holomorphic 4 cycles are appearing, which are these orange nodes fibered over C2. And the result is even easier than before, in which you can see for all the tower of SU odd gauge groups, this result. This is odd whenever the class is odd here. The interpretation is a little bit more complicated because so we don't have open strings ending on the orientifold clearly. So we argue that these candidate C4 we are using here are actually lifting loops of closed non-orientable strings which just intersects the D7 stack in our candidate C2. Okay, I conclude. Just mention that this procedure works also for SU2n case because the orientifold is also there, and it's also lends better itself to treat the U1 restricted cases, which we also did in our paper. Okay, let me conclude with an outlook. There are various open questions, of course. So first of all, some technical points. So we found that for the SUN series it's the non-spinness of the normal bundle of the D7 stack in the base B, which decides the quantization of G4. But for the SPN series, it's the tangent bundle that matters. Of course, the two things are equivalent in case the base of the elliptic vibration is spin, but in case it's non-spin, I mean, we don't understand. I mean, some clarification is needed. Then the SU3 case, you may have realized that SU2n plus 1 series started with SU5 because we couldn't understand the SU3 case. I mean, in the sense that we could find an odd value for C2 in F-theory configuration with SU3 gauge group. So we don't understand, and this might be due to the fact that it has an anomalous enhancement on the O plane, which is not SO6, but is the code IRA for split, some other code IRA singularity. Now, a little bit more in general, the picture outlined may be useful for various global consistency checks. One of them, for example, just to mention one, is that to make sure that the M2 anomaly does lead only to well-defined chiral indices. So then this is actually another very important point. So Sen limit of the SUN configuration always lead to conifold singularities, which no one is able to resolve. And an appropriate treatment of them is crucial for deciding on topological matters like computing Chern classes. And finally, I have not discussed this part of the Freed-Witten anomaly, that the one that constrains the topological type of G4 to be pure torsion when restricted to the M5 brane-Ward volume. So, I mean, it would be interesting to analyze this condition using the MF theory duality and to see what is the consequences of this condition for the corresponding type 2B instantons, which corresponds to this M5 brane instanton in M theory. Okay, thanks. Sorry for the delay.
Questions? Yes.
So, if I understood properly, you detected the anomaly by sort of intersecting with some Whitney umbrella, for example. Is it guaranteed that you will always have a Whitney umbrella in the background, or you sort of put it as a probe?
No, we are discussing the cell limit of SU to N configuration, so we expect that there will be, I mean, unless you cancel the tadpole completely with the D7 stack, yeah, I would expect a Whitney umbrella shaped D7 that cancels the tadpole. Yeah.
So this is not a probe argument, this is really...
No, absolutely, absolutely.
Any more questions? Right, let's thank the speaker.